very much. So I will talk about a topic that's related to how can development of new vaccines, platforms such as mucosal vaccine be encouraged. Next, please. So this is a slide taken from a textbook that demonstrates that there are millions of deaths that's caused by a variety of pathogens that infect through the mucosal surfaces. And of course, SARS-CoV-2 adds to this list of causing not only deaths in millions, but also with respect to long-term disability that's caused by long COVID and many other issues. Next, please. Oh, this just added a bar in addition to the existing knowledge about various infections causing deaths for COVID. Next, please. So I'm going to make a case that mucosal vaccines are better than intramuscular vaccines in multiple aspects. Next, please. We've seen throughout the pandemic that there are multiple factors that contribute to breakthrough infections following vaccination. And that has to do with waning immunity, as well as some reduction in B and T cell responses over time. Next, please. And we know that the intramuscular vaccines are excellent in generating systemic immunity, and there's some access of IgG to the lower respiratory tract. However, when you look at the upper respiratory tract, nose, as well as in the oral cavity, we really don't see much of a response generated by systemic immunization. Next, please. Combined with the fact that there are a number of variants of concerns that emerge that with every emergence with increased immune evasiveness and transmissibility, we are really dealing with a situation where vaccines are no longer able to prevent infection and transmission. Next, please. So the ultimate goal is to generate mucosal immunity, which can, in theory, provide sterilizing protection. And even if that's not possible, a rapid recall responses that depend on specific effector molecules, such as airway mucosally secreted secretory IgA, which is dimeric and multimeric, as well as some exudates of IgG, as well as transported IgG into the mucus layer. We can also establish tissue-resident memory cells, CD4, CD8s, and B cells that can provide a rapid recall response in order to prevent infection and replication and transmission of the virus going forward. Next, please. Oh, so there are some problems, and we think there are solutions also to nasal vaccines. Next, please. So if you look at the currently licensed vaccines, many of these are live attenuated vaccines that require significant R&D, and safety is very important for these types of vaccine strategies, and are not usable in immunocompromised individuals. There is only one available respiratory mucosal vaccine, the FluMist. FluMist, even though it works quite comparably to the intramuscular vaccines, it sometimes loses its effectiveness based on the type of attenuation that it requires, as well as potentially anti-influenza virus antibodies preventing the uptake of such vaccines in the nose. And there's also a safety concern that's particularly important to consider for nasal cavity, because it is close to the CNS via the olfactory bulb. So it does require extra safety precautions. Next, please. So we came up with a solution, and we're not saying that this is the only solution, but one possible example of a solution is to do a strategy called prime and spike, where we can elicit immune responses with the conventional vaccines or even potentially prior infection. And then we can robustly redirect that response to the nasal cavity through a nasal booster strategy. And Ben Israelo and Tianyan Mao are the kind of lead investigators for this project. Next, please. So the idea is very simple. Many of us have gotten some sort of vaccines. This here is the mRNA LNP vaccine, but we can also combine it with other types of vaccines to prime the immune responses that generate circulating memory cells. Next. And then we can follow this up with a mucosal spike boost. This can be either a recombinant spike protein or mRNA encoding the spike protein encapsulated into a safe nanoparticle. And this way we can redirect the immune responses to the upper and lower respiratory tract. Next, please. And with this kind of strategy, we've demonstrated that the low level of sort of immunization by just using very small amount of mRNA vaccine, this can be boosted by a spike booster vaccine to provide 100% protection against death and weight loss. Next, please. And we can also reduce the viral load in both the lung as well as nasal turbinate and prevent pathology within the lung. Next, please. And we can also combine different types of booster in the nasal booster strategy. Here, we're using SARS-CoV-1 spike protein, just some very distantly related spike protein from SARS-CoV-2 to sort of broaden the immune response, in particular antibody and T cell responses against the new spike protein that's introduced nasally. And this demonstrates the fact that such a booster strategy works very well to generate IgA responses as well as IgG against the newly introduced spike, in this case, SARS-CoV-1. But what this is illustrating in principle is that we can use this type of combination strategy to broaden the immune response against variants of concern. Next, please. So this type of vaccine strategies can be used to safely induce nasal immunity by just introducing a very simple recombinant spike protein without any adjuvant, because we're leveraging the existing adaptive immune response to stimulate the antigen-presenting cells to create mucosal immunity. And by combining different types of spike protein as a nasal booster, we can also generate cross-reactive immunity against distant viruses or even variants of concern. And then ultimately, we've also shown in a hamster model that the prime and spike can reduce viral replication and transmission in that setting. Next, please. So the question about how can development of new vaccine platforms, such as nasal vaccines, be encouraged? Well, we think we need a government support related that's needed to develop and translate mucosal vaccines. So Eric Topol and I wrote an opinion piece calling for Operation Nasal Vaccines at lightning speed to encourage this type of strategy. Of course, as an academic laboratory, it's impossible for us to coordinate an effort that would develop vaccines so quickly as we saw in the first period of the pandemic. And we also need better correlates of protection that reflects mucosal immunity. Currently, correlates of protections are based on serum antibody levels. And that is a very good way to measure correlates of protection for many different vaccines. However, when it comes to mucosal immunity, the serum level of antibody may not be reflecting what's really going on in the nose and the throat or the oral cavity. So we really need a better correlate of protection for these types of vaccine strategies that may require assessment of antibodies in the mucosal secretions, and also make existing vaccines available for research purposes. We don't have access to the current vaccines, and we cannot compare our strategies to current vaccine strategies because of some regulatory restrictions for use of currently used human vaccines. So that should be lifted in order to encourage this kind of new vaccine platforms from being developed. So next, please. Yeah, I'm ending here. Yeah, thank you. By acknowledging the people who are involved in this prime and spike strategy, as well as funding agencies and the entire lab. Thank you.